So today I'm going to do a little illustration how to do the object orientation in a more visual way than we have done before. So what I have here now is an example that uses something called Pi5, which is a creative coding toolkit for Python, which you can really quickly draw things on the screen. So it's not that what is important today. So I'm going to use this as a way of showing how you can benefit of object orientation when you do graphics, for example. So I have here it's called a sketch. So and that is a class in itself which we inherit to specialize. And that class has three methods that we call. So settings, that is called once to set up the screen or the window. Setup is called also once to set up your application. So here you can initialize your variables or your attributes for your class or your application. And then draw here, that is actually where things will happen. So this method will be called repeatedly. So every, I think 60 seconds, 60 times per second. And now it just clears the background. And here is our main application. So we initiate our sketch, and then we just tell the sketch to run, and it will go in that loop forever until we stop the application. So if we run now here, we get just an empty window, 600 by 600. So nothing fun. But what we can do is we can do here we can do sketch. And we could draw a line. And line takes multiple version, but the easy one is X coordinate, Y coordinate, and two pairs of coordinates. So we can do for 50 by 50 to 150 by 100. So these are pixels in the window. And if we run this again, you will get a line here, like this. So it's a very easy, there is a lot of built-in functions for drawing different things. So what I was going to do is to show you how you can implement some objects that can draw themselves on this canvas. So what the first thing we will do, we will create our own class. So in this case, we just do a very simple one called point. And we need an initializer, a constructor. So def init self. And we draw, we need some attributes. So we need the point to have a coordinate. So we do self.x equals to 0. And we need something to, a method to be able to draw itself on the screen. So we call it draw. Very creative. And then we do sketch. So sketch is a global variable. So when I created this sketch object, to make it accessible everywhere, you can do global here. It's not the best way of doing it, but it works. So it will have all the drawing commands for us. So we do sketch dot stroke. So this is the tells how a wide line should be. And you can also do sketch dot stroke width. Weight. So that is the width of line, for example. Also for the thickness of a point. Otherwise, the point is very hard to see. So sketch dot point, and then we draw it at self.x like this. So the first thing we need to do is to create our point. So we can do self. So because if we create a point like this, it will go away after the setup has finished. So if you create variables, they're just local to the function. So to be able to use it in the rest of our sketch here, we need to add self here. Then it's attached to the sketch object. And then we need to set a position for it as well. So self.p.x50, like this. And then we need to draw the point as well. So self.p.draw. So hopefully we should see a point if we are lucky. Yes, there is a small dot there. What we also can do is we can create a list of points, for example. So we can do self.points. Just make an empty list like this, and say we do for I in range 100. So we do 100 points, and then we do p equals to point, p.x equals to, I think there's a sketch.random. So we see 600. We will get all this code. We have it's in the repository later. So 600. And then we just do self.points append, so it adds to the list. And the reason I do p without self here is because I create a new point and I add it to the list. And the list will maintain all the points in the system. So you don't need to use self.p here in this case, but we need to have the list must be available to application. Then I can remove this one here. And then I can now I need a way of drawing all the points. So we can do for p in self.points. And then we can just call p.draw. Yeah. So now we have created an object or a class that can draw itself, and we can create a list of points that we can draw on the screen. So every point here is its own object, and it has a x and y attribute that it stores its position, and it knows how to draw itself. And we can also create another class here. Let's see if we do a circle. We could derive this from the point here if we want, so we can inherit the x and y. And we do. Now we have to initialize the point as well, the point, so x and y coordinates. So we do super. Like this. So super is the inherited class. You get the reference to that, and then you can call init on that. And here we also add a self.r equals to, let's see, 30. And then we need to override the draw again. So always if we do classes, we all need to have a self parameter as the first parameter when we define it. And then instead of a point, we would do, now there is no circle, we need to use ellipse. And there should be, so we can do self.x. I just do shapes here instead now. So instead of points, now we can have circles in that as well. So we do circle. And now we also have, now we can see. I spelled it wrong. So now the circles will be drawn.
Even though you define your new circle class as a subclass.
Right?
Your new circle class is a subclass of point, but you still have to call the constructor from your super.
Yes.
It's even though you actually explicitly said this is inheriting from point.
Yeah, that's unfortunate. It doesn't do it automatically. So you
Yeah,
need to call the inherited constructor. Otherwise, the attributes will never be added to the subclass.
That's a bit weird, like you have to specify.
Yeah, exactly. And I think in C++ you don't do that.
Nor in Java.
Yeah, exactly. But
it just says like it inherits from.
Yeah.
And then runs the constructor from your subclass.
Let's see here. Circle point. It's something called, so because by default, when you draw a circle in Sketch, it's drawn from the top left and like a rectangle. So what we need to specify here in the setup is also something called self dot ellipse mode. So this is just for this drawing library, self dot center. And now I think we should see. We haven't set. Yeah, we set it. Yeah, you can see now we have circles instead. And the thing we didn't do here, we just now it used the default R here was 30. Of course, we can do s dot r equals to sketch dot random start from 20 to 100. So there is a random function in the sketch library that you can set a random number between two ranges as well. So now we should have a mixed bag of circles like that. So each of them, each object has its own X, Y, and R, and that's why it can draw itself. And then it has a method to draw itself on the screen. And what you also can do, because Python can store different objects in lists, we can, of course, have another loop here to instead have points here. And that should be a point of points. And then we remove the R here. Shapes append P. So this is what I call polymorphism. So it can determine which draw function to call here, depending on what the type of the object is in the shapes list. So now we should have a mix of points and circles. If we just comment out the circle draw function here, like this, and we run it, you can see here that it finds that, okay, circle does not have a draw, so it moves up in the hierarchy to the point and uses that for drawing instead. So this is you specialize here the circle to be able to draw itself, and then that overrides it because it will find draw first in the circle instance and then use that instead.
Can you use overloading method overloading?
Yes. But there is no concept of virtual here, so everything is virtual in that sense. So that was a very simple example. So I will do a bit more complicated example with. So as points can store information, so you can very easily make a particle system. So let the point have a speed and be able to move itself as well. So I'm going to start with a little bit more complicated template. So So in this example here, I have created a base class here, which will it's not used directly. So so I want every object in my drive objects to be able to have a color for the lines, but also color for the fill. So in this example here, I put all the default things I want to have for all objects in a base class. So here I store color. So color consists of red, green, and blue components. I have a fill color here that is white. Alpha here is also you can have transparency. And I also set the line width to 1. And also, I don't want to override. So some of these functions will be needed for all the objects. So instead of overriding the draw and copying all that code, I've created a top-level draw function that will be delegating the actual drawing to a separate routine. So then I don't have to override, copy this functionality in every function I have, every derived class. Instead, I first set this in the base class, and then I call on draw here for the base, the other classes here. So when you want to implement a circle, you just have to draw a circle. The other things is already done for you in the draw. So we will re-implement the on draw here, and you can see here I have just a empty draw function here for this base class. And that is just to kind of be able to easily implement the functionality that differs for the different objects we implement. So what I want to do is, the first thing I want to implement is a particle. So, and of course we need a def init self. And here I specify that to be easy to create particles, I give it, you can instantiate them with an X and Y coordinate. And I use default parameters here. So if the user doesn't give these parameters, X and Y will be set. So you can have, that is called default parameters in Python. And that's a really powerful thing that you can have an easy way of calling a function with defaults, and you can specify additional parameters if you want later on. Then we do call the super init here again to initialize the base object. And I don't have any parameters on that. You can see here that there is an empty, so I can just call an empty here. Now we have to initialize, the particle needs to have a point. So self.x equals to x, self.y equals to y. And then we define a speed for the particle as well. So self.vx equals to 0 first. Self.vy equals to 0. Now we also need, for the particle, we also need to be able to update its position on the screen. As update this particle simulation. So we add an update function here, update self, and then a delta t here. So we specify a time step. And then so this is not a very much sophisticated particle system. So it's not what we are going to teach here. So I'm going to make it very simple. So in this case, we just do self.x plus equals to self.bx times delta t, self.y plus equals to. So this plus equals is the same as typing self.x equals to self.x plus. So you save some typing.
Why is there no plus plus or minus minus operator in Python?
You have to ask Guido. He probably didn't like them, so he didn't implement them. Let's see here. Yeah, then we need to draw. Just going to close my team session here. Yeah, sorry for that. Def, we need an override on draw. And then we just very simply draw a point here, sketch dot point. But I would like to have a bit more nice particle. So I want to implement a round particle. So we do that, class round particle, and we inherit everything from the particle here. Move that. Self. So here we have the same thing as for the particle. So we need to have the x 0.0 here, y equals to 0, 0, and then we also have a radius here. Radius equals to and then we need to do super. We initialize the particle instance as well, a particle class. We pass an over x comma y here. So this way you need to, because particle has x and y here, it's a good idea to also you have to pass them along here over. So we go x and y here to the upper. So this will call this routine that is called the base level, and then continue initializing these variables here. And now we can initialize our own here. But in this case, we don't need anything special except for the radius here. So let's do that. So self dot r equals to r. Now we don't have to override the update method because that can be kept. The only thing we have to override here is the def on draw, like this. And now we do sketch ellipse instead. Self.x, self.y, self.r times 2. I was a bit more clever here. Self.r times 2. To contain our boundary, our particle system, we also need some kind of boundary clause that we can check that the particles are inside a certain boundary. So I will not type everything here, so I will just copy that from another code here. So it's like the cooks in TV. I have prepared this here.
Bouncing on the edges.
Yeah. We put this here. So this is just it has x min, x max, x y min, y max, and I just put some values here. And then we check here, is it inside? We also have a check here that checks, reverses the speeds of the particles when they hit the boundaries. Very simple. But I contain that functionality inside this box boundary. So next we need to implement our particle system as well. So we go down to the setup here and we can, let's see, we'll remove that. No, I'm wrong. in wrong class. This one here should go here. And down here in my particle system, now we need to set it up here. So what we need a set of particles. So we will do a self particles list, which is empty. We need to create a boundary object. Boundary this equals to box boundary. We accept the default, so because we have a screen that is 600 by 600, it should stay inside that window. Now we have to create some particles. So we do for I in range. Let's see, do 100 particles. We create a particle equals to round particle. And here we do self.random. We create them from 6 to 600. And then we set the radiuses here to random 3270. Now we need to initialize the speeds. So we give them p.bx equals to self.random minus 60.0. And now we also need to make it a bit more flashy. So we change the colors here. So P fill color equals to this random. So colors are given from 0 to 255. So we just give them random colors from 0 to 255. Like that. And then we also do a random alpha here, so to make them semi-transparent. So we do fill alpha. We don't make them completely transparent, we just from 50 to 255 here. And then we add self particles dot append P. So now we have a list of particles that we want to draw and simulate. So let's go into the draw loop here. We do loop over here. So for particle. I do P, that's easier to write. In self particles. And now we know that by default, this environment will update the screen every 60 seconds, or 60 times per second. So we know the delta time. So what we can do then is p.update. So we loop over every particle and we update it 1.0 divided by 60, like this. And then we check the boundaries, self.boundary check P. And then we do P.go. So now hopefully this will work. Yes. So here you can see so now we have created an object that knows how to draw itself. It has attributes like color, line thickness. It has a position, but now it also has speed, and it also knows how to move itself. So in this way, you can do particle systems. You can do other simulation objects. You can, and also one thing that we'll see later on is when you do user interfaces. You have buttons, checkboxes, and all that stuff that lends it very well to objects and classes. inherit from each other. And we can create boxes here or lines that moves as well. We can just inherit from the particle and modify the on draw method to draw something else. And we could, if we do, we can do a very boring particle here as well. If we do P particle here, we skip the radius here. Well, now if you can. We don't have. Okay. So that didn't work because the boundary box checked for the radius of the rounded objects to bounce correctly. So yeah, that's why it didn't draw some points. Otherwise, it could have. What you could do is just remove this one here. Then you get the boring particles. I think they're 1 pixel wide, so it's difficult to see. So hopefully that with this demonstration, I want to do something that was not so dry and illustrate the concept of object orientation. That it can be a very powerful concept. Now, I don't say that you should implement your particle systems like this because it's not very efficient to store an attribute for every particle. If you have millions of particles, you will have millions of objects. And if you want to simulate millions of objects, you should use arrays and actually simulate array computing to update the particle systems. For smaller things, to do stuff like this, it works. But for larger things, you have to think about it a bit differently. You should perhaps have a class that is called particles. And that class can update the set of particles instead of every individual particle. So that was what I wanted to illustrate today. And I will stop the recording here now.